A few years ago, Nvidia was still mostly known in the public imagination for graphics cards, gaming PCs, and the glowing hardware inside enthusiast computers. Then artificial intelligence exploded, and the meaning of Nvidia changed almost overnight. The companies building the new AI economy all needed the same thing: enormous amounts of accelerated computing. Microsoft, Google, Amazon, Meta, AI labs, startups, governments, and cloud providers were suddenly competing for access to Nvidia's most advanced systems. The demand looked like a sudden shock. Data centers expanded, server rooms filled, and AI clusters became one of the most valuable resources in technology. But the deeper story did not begin with a chatbot or a single product launch. For viewers, it felt like a switch had flipped, but inside the industry, the build-out had been gathering force for years. Media had spent decades building the pieces: GPUs, developer tools, software libraries, systems, networking, and a culture around accelerated computing. When AI finally needed that stack, Nvidia was already standing at the center. That is the difference between a boom story and a preparation story. The boom made the preparation impossible to ignore. So the real question is not only how Nvidia became valuable. The better question is whether this was luck, or whether Nvidia had been preparing for a future most people could not yet see. This is the story of how a company associated with games became the infrastructure company behind the AI boom, and why the same position that made it powerful also made it a target. To understand that rise, we have to go back before artificial intelligence was mainstream, to the original reason Nvidia mattered at all: graphics. Before AI made Nvidia unavoidable, graphics made it famous. The company's chips helped computers draw faster, smoother, richer visual worlds, especially in video games and 3D applications where millions of tiny operations had to happen at speed. A GPU was not designed like a traditional general-purpose processor. It was built to handle many similar calculations at the same time. At first, that power made games look better. Later, it would make machine learning possible at scale. The same architecture that could shade pixels quickly could also attack mathematical workloads that looked nothing like games. For years, many people saw Nvidia through the lens of gaming: faster frame rates, better shadows, more realistic worlds, and expensive cards inside custom PCs. That reputation was real, but it hid a more important idea. The deeper business was not simply graphics, it was parallel computation. Nvidia was learning how to sell chips that could process huge numbers of repeated operations quickly, exactly the pattern future AI systems would need. This is why the gaming chapter matters. It gave Nvidia volume, engineering discipline, developer relationships, and a constant reason to push performance. The consumer market trained the company before the AI market rewarded it. But hardware alone was never enough. Nvidia needed someone to keep widening the company's definition of itself, even when the world still thought of it as a graphics card business. Jensen Huang co-founded Nvidia in 1993 and remained its long-term leader. His role was not just to sell chips. It was to keep pushing the company into larger definitions of computing, often before those markets were obvious. The company's endurance matters because this was not a one-product pivot. It was a long expansion of what accelerated computing could mean. The public image became familiar. Huang on stage, the leather jacket, the product reveals the language of platforms and computing eras. But behind that image was a strategic pattern: repeated bets on markets that looked too early. Nvidia lived through cycles, competition, crypto booms, crypto busts, gaming downturns, and skepticism about whether GPUs could matter beyond graphics. Surviving those cycles mattered, because the company kept investing in the future while demand was uneven. Each cycle forced Nvidia to keep one foot in today's demand while funding bets on tomorrow's workloads. Huang's long game was not to abandon gaming. It was to turn Nvidia into something larger. A company that could power graphics, scientific computing, data centers, AI research, and eventually the infrastructure of generative AI. That strategy only makes sense once you understand why GPUs were so useful for artificial intelligence in the first place. A simple way to understand the difference is this. A CPU is like a small group of very skilled workers handling complicated tasks one by one. A GPU is like thousands of workers doing many simpler calculations in parallel. Modern AI depends on massive amounts of repeated math. Training large models means adjusting billions of parameters again and again. Running those models also requires heavy computation, especially when millions of users ask questions at the same time. That is why the GPU became so important. It was not magic, and it was not only graphics. It was a machine built for parallel work, and deep learning was one of the biggest parallel computing problems the market had ever seen. That fit between problem and architecture became one of the quiet foundations of the modern AI economy. The hardware kept evolving. Memory, interconnects, specialized cores, and system design all mattered. But the core idea stayed simple. AI needed many calculations at once, and Nvidia had spent decades getting better at exactly that. This is also why the AI boom did not turn every chip company into Nvidia. The market did not only need faster chips. It needed hardware that researchers and developers already knew how to use. And that leads to the part of Nvidia's story that is less visible than a GPU, but just as important, CUDA. If the GPU was the engine, CUDA became one of the ways developers learned to drive it. CUDA gave developers a way to use Nvidia GPUs for general-purpose computing, not only graphics. That changed the relationship between the chip and the people building software on top of it. Researchers, engineers, and companies could write code that used Nvidia hardware for scientific computing, machine learning, simulations, and later deep learning. Over time, this created habit, tooling, libraries, and trust. This is what people mean when they call CUDA a moat. A moat is a business advantage that makes a company harder to attack. Nvidia's moat was not only silicon, it was the ecosystem around the silicon. The strongest moats are often invisible because they live in habits, workflows, and switching costs rather than in one physical product. Competitors can design accelerators. Cloud companies can build custom chips. But replacing a mature software stack, developer knowledge, and years of optimization is a slower and more painful process. That software layer turned Nvidia from a component supplier into something closer to a platform company. The chip mattered, but the chip was only one piece of the system. And once AI workloads moved from labs into cloud data centers, that platform became dramatically more valuable. The center of gravity moved from the gaming PC to the data center. Nvidia was no longer only helping consumers render worlds on screens. It was helping companies build the compute factories behind artificial intelligence. This is the moment the story stops being about a card inside a machine and becomes about machines inside entire buildings. Cloud providers needed GPUs to sell AI compute. AI labs needed GPU clusters to train models. Enterprises needed infrastructure to experiment with AI. The demand was not one market, it was a chain of markets pulling on the same supply. This is where the business transformation becomes visible. Gaming was still important, but data centers became the engine. Nvidia's annual reports show how sharply that segment expanded as AI demand accelerated. It is one thing to say a company changed. It is another to see the revenue base move toward a different center of gravity. The old public image was a graphics card company. The new reality was infrastructure. GPU systems, server platforms, networking, software, and full-stack AI computing sold into the most important technology build-out of the decade. That change did not happen in a straight line. Semiconductor markets are cyclical, and demand can move violently. But by the time generative AI became mainstream, Nvidia had already built a data center business ready to absorb the surge. The desk had become a server rack. The gaming chip had become the foundation of a new industrial system. Inside that system were products like DGX and H100, not just chips sold in isolation, but integrated platforms for enterprise and AI workloads. AI research had been building for years before the mainstream explosion, but after 2019, the story accelerated: larger models, more data, more compute, and eventually generative AI systems that turned AI from a research story into a boardroom priority. When large language models became widely visible, companies did not simply need software. They needed clusters, thousands of GPUs, fast networking, reliable systems, and the tools to make all of it usable. That is why the explosion looked sudden, even though the preparation took decades. Nvidia had spent years building the hardware and software stack that the AI moment suddenly made urgent. After 2019, the numbers began to show the shift. Gaming still mattered, but data centers became the story. Nvidia was no longer only selling chips to gamers. It was selling compute to companies trying to train and run the next generation of AI systems. The stock market noticed, but the stock market is not the main story. The important point is that real customers were buying real infrastructure, because AI ambitions without compute were only ambitions. By the middle of the boom, Nvidia had become more than a supplier, it had become a bottleneck. If you wanted frontier AI capacity quickly, the road often passed through Nvidia hardware. And bottlenecks create power. AI labs depended on Nvidia to train bigger models. Cloud companies depended on Nvidia to sell AI compute to customers. Startups depended on access to Nvidia-powered infrastructure they could not afford to build themselves. In AI, compute became both a cost center and a strategic weapon, which made access to Nvidia hardware unusually important. This created a rare strategic position. Nvidia sat between the ambition of the AI industry and the physical reality of building enough compute to satisfy it. When everyone needs the same supplier, the supplier gains pricing power, influence, and visibility. But it also becomes the company everyone studies, negotiates against, and eventually tries to reduce dependence on. This is why dominance can be uncomfortable even for the dominant company. Every customer wants leverage. That tension is central to Nvidia's story. The company became powerful because customers needed it. But the more essential it became, the more those same customers had reasons to search for alternatives. In other words, the AI economy did not just reward Nvidia. It organized itself around Nvidia, at least for this stage of the boom. That is why Nvidia's business model matters. It is not merely selling chips into a hot market. It is selling a stack. Nvidia sells GPUs, but also systems, networking, software tools, libraries, and complete infrastructure. The more pieces a customer uses, the deeper that customer becomes connected to the Nvidia ecosystem. The simple gold rush metaphor says Nvidia sells shovels. But the better version is this: Nvidia sells the tools, the roads, the maps, and much of the machinery needed to run the AI gold rush. This is what separates a component company from a platform company. A component can be swapped when something cheaper appears. A platform becomes harder to replace because workflows, people, software, and infrastructure grow around it. That platform strategy is why Nvidia's rise is not only a hardware story. Hardware opened the door. Software, systems, and developer adoption made the position much harder to attack. But no position that valuable stays uncontested for long. The first risk is dependence itself. Big technology companies do not want to rely forever on one supplier for the most important infrastructure of the AI era. Some are building custom accelerators to control costs, supply, and performance. The goal for these customers is not always to beat Nvidia outright. Sometimes it is simply to gain bargaining power and supply security. The first risk is substitution. Google has TPUs. Amazon has Trainium and Inferentia. Meta has MTEA. AMD and other chip companies are attacking the accelerator market. None of this means Nvidia disappears. It means the customers who need Nvidia also have strong incentives to reduce dependence. The second risk is cyclicality. Semiconductors can swing between shortage and oversupply. If AI spending slows, if model economics disappoint, or if customers pause expansion, the same growth expectations that helped Nvidia can turn into pressure. The third risk is geopolitics. Export restrictions, China exposure, and supply chain concentration can affect what Nvidia can sell and where it can sell it. Advanced chips are no longer just products, they are strategic assets. Rules can change faster than product roadmaps. The final risk is manufacturing concentration. Nvidia designs much of the intelligence, but advanced production depends on a small number of specialized partners, locations, packaging systems, and manufacturing steps. The center of the future is also exposed to the world around it. So why did Nvidia win this stage of the AI boom? Not because it got lucky in 1 year. It won because decades of GPU development, CUDA, developer loyalty, systems engineering, and data center strategy all met the same moment. The company was ready for a future that looked too early, too technical, and too niche for most people to care about. When that future became mainstream, Nvidia was not chasing the market. It was already inside it. Nvidia did not just sell chips to the AI boom, it became part of the infrastructure beneath it. But every empire that becomes too important creates the same reaction. Everyone depends on it, and everyone eventually looks for a way around it.